Welcome to CEC lectures. Myself, Dr. Preeti Jagwani. I'm Associate Professor, Department of Computer Science, Aryabhatta College, University of Delhi. In the series of our, programming in Java, in our previous lectures, we have gone through so many topics in detail. Like we have started with the basics of Java. Then moving towards the object-oriented programming paradigm, we have gone through the objects, classes, and constructor too. And for in this series, our today's topic is the static keyword. Now, static, this is actually, it is a common keyword, I can say, or it is having, it is a keyword which is familiar to most of, most of us, and like other languages, it is having its own special importance in case of Java, if we talk about. So today, this is what we are going to discuss, that is the static keyword, specifically with reference to, how and at what all places it is going to be used in this programming language. When we talk about the keyword static, let me make it very clear that static keyword is actually a kind of modifier. I can say it as a non-access modifier in Java, and it is applicable to blocks, it is applicable to variables, it is applicable to methods, and it is also applicable to classes. And all these all these four, which is blocks, variables, methods, and classes, that we will be looking in this lecture, that how this static keyword is kind of modifying them, changing them, or how we are going to use this static keyword with reference to the class and the methods and the variables and the blocks itself. With using our previous knowledge, let's say if we are going to define a class member that is going to be used independently of any object of that particular class, and in such kind of situations we are going to use static. So, for example, a normal class member which we have, be it a method or be it a variable, can only be used in conjunction with an object of its class. So, for example, within a class we have a variable and we have a particular method, and when we are going to create a object of that particular class, along with that object we will be using that method or that variable. But in the programming language, it is possible to create a member that can be used by the class itself without reference to a specific instance, without reference to a specific object, and that class member which is going to be used independently of any object of its class is going to be the static member. So, in order to create such a member, we need to use the keyword static, and that keyword static has to be kind of, we can say, used or written before the declaration of that particular member. And when a member is declared static, it can be accessed before any of the objects of its class are created, or we can say without giving any reference to any of the objects of the class. Now, when I am talking about the class member, that means the methods as well as the variable instance. Methods and variables, they both can be static, and the most common example of the static member as far as our Java is concerned is main. So, please recall that within a class, when we are going to define a main, we write some keywords before in the signature of the main, that is public, static, void, and then we use main. So, here that our main is actually an example of an static member. Now, main is declared obviously as static because it must be called before any object exist. And please recall that while creation of while compiling any of the program which is having a main function, we just don't we never created the object of that particular class in which the main is enclosed, and despite of that we use that main function, we run that main function, and program executes and so on and so forth. And but we have not created any any member, any object, any instance of the class which is having the main function. Why? Because this is possible because our main is an static function. Also, when we talk about the variables which are declared as static, so all the instance variables which are declared as statics are essentially considered as global variables among all the objects of the class. So when the objects of this objects of the class are declared, no copy of a static variable is made, only one kind of one we can say version or one copy of that static variable is available, and that has to be shared among all the objects. So this is actually giving us a flavor of I can say a global variable, and all the instances of the class will be sharing the same static variable. Now when we say about what kind of scenarios are there in which we are going to use these static variables. So for example, let us say kind of very common scenario in which we are kind of making a making a program which is going to create which is going to count how many objects of a particular class are going to be created. That means every time an object has to be created, that counter or that variable has to be increased by 1. In such scenarios we can use static methods. Now when we talk about the methods which are declared as static, they have several restrictions. As in they can only directly call other static methods, they cannot call non-static methods. They can only directly access static data directly. Here the term directly is having its special significance. I will be talking about this using an example. And these static methods cannot refer to this keyword. This keyword we have already covered in our previous lectures. So they cannot refer to this keyword, and they also cannot refer to the keyword super. Super keyword we have not kind of I can say gone through till this point, but yes, soon when we will be kind of covering the topic of inheritance, we will be looking into this super keyword. So this keyword cannot be used using along with these static methods. Static methods cannot directly call other non-static methods, and they can only call the static data directly. And we have seen that what other kinds of static objects, static elements will be there. There can be blocks, there can be variables, there can be methods, and there can be classes also. So the static keyword in Java is applicable to all these 4 entities. Before going further with static keywords, let us try to understand that what all are the features of the static keyword. So as I have told you that only one copy of an static variable is going to be kind of created, and all the objects, all the instances are going to use that particular copy only. So from here the characteristics which is actually coming out is about shared memory allocation. So shared memory allocation, we can say static variables, not only static variables but static methods also are allocated memory space only once during the execution of the program, and that memory space is going to be shared among all the objects of the class, which makes static members useful for maintaining global state or shared functionality. So let us say we have a global state, and what kind of global state I am talking about? That is kind of counting the number of objects. That is something global to that particular program, or global to that particular class. So in case of such global for maintaining such global state or shared functionalities, we will be using the static method, and shared memory allocation is provided. Then as I have already told you, the second characteristics which comes up is that is this is accessible without any object instantiation. So the static members can be accessed without the creation of instances of the class, and because of this property they are useful for providing utility functions and constants that can be used across the entire program. So here again, kind of we can say the idea of this global shared memory allocation, or that global flavor comes into the picture. And as these static members can be accessed without creation of the instances of the class, that means we can we can deduce that these members are associated with class, these are not associated with any objects. So static members are associated with the class, not with the individual objects. And this means that changes to the static members, if any we are going to make any change in static members, they are reflected in all instances of the class. Access static members using the class name rather than the object reference. So in order to use, or in order to access the static members, we will be using the name of the class rather than the name of the object, because these are associated with the class, these are not associated with any of the we can say objects. Also, as we have seen in the restriction, one very important thing about this static is they cannot access non-static members. That means whether there is a static method or whether there is a static variable, they cannot access members of the class which are non-static, as they are not associated with any particular instance of the class. If allowed to use any non-static members, that is going to give us a conflict between this shared and the global flavor and with this property. Also, these static methods cannot be overloaded, but yes, they they can be they can be overloaded, but they cannot be overridden. So static methods can be overloaded, which means that you can define the multiple methods with the same name but different parameters. This is what actually our overloading is. And overriding, if we talk about overriding, is such a concept that we are going to we will be taking in our upcoming classes. So please make a note of that. Yes, static methods can be overloaded. That means we can have multiple static methods with the same name but different parameters. However, they cannot be overridden, as they are associated with a class rather than a particular instance of the class, and because of this they cannot be overridden. Now, the one fact which is well established here is when a member is declared as static, it can be accessed before any objects of the class are created, and this is and without reference to any of the object, and this is what we actually kind of did right from the starting in our first program, which was kind of an hello world program, and it was printing just the hello world thing. In that program also we have used main. That main has been called, and because as a consequence that hello world is being printed, and in calling the main we have not defined any, or we have not declared any of the we can say access any of the objects of that particular class. Now, in order to, with kind of so much conceptualization about static keyword, or we can say static members, or static methods, let us try to see this with the help of a program in which we are going to use a static member, and here that static member is actually a static method. Now, here we have a class test in which we have a static method, and that static method is being shown here on the screen. This static method is named as M1. It is not having any of the it is not taking any of the argument, it is actually not returning anything. So void is there, an empty parenthesis, and in order to declare it as static, we have preceded this with the static keyword, and this static keyword is this static method is doing nothing but actually printing from M1. That is the scene. And within this class test we have another static method which is main, obviously, and this main we have been using since our first program, and here this main is going to call that particular static method without creation of any of the objects of the class test, and M1 is being called within the main. Now main itself is actually, we can say, is static here. So in order to use this particular class, we are going to we are going to do the same procedure, that is, we will be compiling this particular program using Java C test Java, and then we will be using we will be saying Java test in order to execute that. So this was actually, we can say, the scenario in which these static methods, we have created one static method, and that is used before creation of any particular object of this class test. And when we are going to kind of execute this particular program, the output will be from M1. That particular term will be kind of, we can say, printed on the screen. So this was actually about the members, static members, but one thing which is kind of, we can say, unique here is your static blocks. So static block is something which may not be possible in some of the languages, but here in case of Java, yes, having a static block is possible, but the question which comes up in the mind is what is the need of having a particular block as the static block. So block, as you understand, is actually some kind of, we can say, a logical unit of uh, code which is enclosed within the parenthesis. So that's a block. So block starts with an open parenthesis, and you have some kind of execution, you have some code written into that, and then there is a kind of, we can say, closure of that particular block. And if you want to do some computation in order to initialize, or in order to kind of modify the static variables, a static block can be created that gets executed exactly when the class is first loaded. So for example, if you want to initialize these static variables, these variables can be initialized inside an static block, and that static block will be executed only once, and that is executed when the class is first loaded. So how it is going to be, how it is going to happen, let us see this with the help of a example. Again, we have a class test in which we have two static variables. One static variable is integer a declared initialized as 10, and another one is the integer b, which we have not initialized, we have just declared it. And in order to kind of play with, or in order to initialize these static variables, we have started with one static block, and as kind of, we can say, we all are aware that this is going to be a block which is demarked by opening and closing parentheses. But this being an static block, the keyword static is kind of, we can say, prefixed before the parenthesis. And within this static block, we have used one system.out.println, which says static block initialized, and b is equals to a multiplied by 4. And please remember that both of the variables, which are a and b, are actually static, and that's why we are able to use these variables within our static block. So one static block is there which is using the value of a and giving it or initializing, we can say, the value of b. And within this class only we have a main function which is going to print from main. This is going to print the value of a, and this is also going to print the value of b. And then the main methods ends, and then there is the class which is going to end, and the output which is going to be we can say generated by this program is actually shown as yellow highlighted portion here. So output says static block initialized from main, value of a 10, value of b 40. Now let us kind of recall this program again. So static block is once initialized, and when it is initialized, that means when the class is loaded, it is going to print the statement static block initialized. The value of B is, we can say, set here by initializing it with a multiplied by 4, and then when this main is actually kind of, we can say, being called by, when we say Java and then test, then we are actually calling this main function there, and it is going to print from main. So that means this static block initialized has actually taken place even before calling the main. So that's why this static block initialized is about the output which is given by the main, and then from the main it says from main value of A 10 and value of B 40. So that means once when the class is being loaded, the static block is initialized, and here hence we have that term printed as static block initialized, and after that main method is actually kind of, we can say, executed, and value of A and value of B both are printed there. So this was actually a program which is kind of giving us an idea about the static block. Static methods and static variables are something which are very common to the programmers of the other languages also, but static block is something which is kind of, we can say, it's to be learned once more. When we talk about static variables, I have already told you that when a variable is declared as static, then only a single copy of the variable is created, and that copy is going to be shared among all the objects. Essentially they are global variables, and all the instances will use that same static variable. Now in order to understand the concept of this static variables, let us see this static variables, a program which is demonstrating execution of static variables and static blocks in conjunction. So here again we have a static variable. Within the class test we have a static integer A, and this integer A is storing the value of what is being given by the function m1. Then there is an static block which says inside a static block. Then we have a static method m1 which is returning an integer, and that is nothing but 20. And then within this program we have a static function which is one common function, that is main. So here please notice that we have a static variable, we have a static method, and we also have a static block. So a static method is m1 which is returning 20, that value of 20 is being stored inside an static variable A, and then we have a static block which is printing, which is giving you an indication inside static block nothing. Then the definition of m1 is there, which is saying from m1 and returning 20, and then we have again a static method which is nothing but the main. And main, when we say main, is printing nothing but value of A, and it is also giving an kind of it is also printing a term which says from main. Now when we talk about the output of this particular program, so here we have from m1. So from m1 is that means this function m1 or the method m1 is executed. This is going to give us the print of this term from m1. Then the static block is there. So static block, inside a static block is being printed because that is being covered here, if you can see. So a static block is covering inside a static block, but before kind of reaching to this static block, when the this class test was loaded, this is going to first call this m1 in order to initialize the value of A. On this the m1 is being called. So the first statement says the call for m1, and then the call for m1 is a static int m1, and then we have from M1 there, that is being printed, 20 is being stored to A, the execution goes, then it says static block, and then within that static block we have inside static block, and then when we talk about the main method, this main method is going to print, you know, two values. One is the value of A and another one is the statement which says from main. So in this way this whole execution is, you know, going to take place. Now what if when a static method is going to refer a non-static method? So as I have told you initially also that these, you know, kind of this is actually not allowed. So here if we can say we have a static integer variable A and then a normal variable B which is an kind of instance variable, and we have a static method M1 in which value of A we have set it 20, that is perfectly fine because A is the static. But if we are going to make a reference to a non-static variable which is B, and let us say we are going to say B is equals to 10, then this is not going to work, this is going to give us a compilation error. However, if we are going to make, you know, any call to an static method M1, that is perfectly fine, but within that M1 if we are going to call the function M2 which is not a static method, here if you can see it is just a normal method, calling this M2 inside M1 is going to result a compilation error. So within a static, you know, kind of method, either we will be using you know, the static variables, or we will be using static methods only. Any reference to the non-static variables or non-static method will give you a compilation error, and then, you know, this is clear from this program. And also there are certain situations where we are not supposed to use these static variables. We have various situations in which these static variables and methods are to be used. So these are actually we need to use for those properties which are common to all objects. For example, in a class student, if a student share the same college name, that can be a static thing, and using static methods for changing the static variables is a common thing. Now from all of these, you know, kind of elements, we have seen static methods, we have seen static variables, and we have seen static blocks also. What we have not covered here is actually static classes. That is altogether, I can say, a separate topic, but I will give you a little, you know, kind of idea about it. So static classes, or I can say a class, can be made static only if it is a nested class, and nested class we need to, you know, kind of go through. We are yet to cover that static nested class, and we cannot declare a top level class with a static modifier, but can declare a nested class as static, and these type of classes are called nested static classes. Nested static classes does not need a reference of the outer class. So here in this lecture we have, you know, covered the static keyword, and we have seen static methods, static blocks, static variables, and also we have, you know, tried to understood, or we have, you know, just seen very briefly what actually this static classes is. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I'll see you in the next lecture. Till then, take care. Goodbye.